A floating dock can look perfectly safe from shore, while loose connections, damaged floats, worn rollers, corrosion, or failing anchors are hiding beneath it. And the connection between land and water, the gangway, is often where movement, changing water levels, and everyday foot traffic come together. So how do you inspect a floating dock and gangway properly? In this video, I'll show you a practical step-by-step inspection process covering the walking surface, frame, flotation, anchoring, utilities, transition points, handrails, rollers, hinges, and warning signs that may require immediate action. By the end, you'll want to know what to inspect, what problems to document, and when to bring in a qualified marine contractor or engineer. Before beginning, remember that this is a general visual inspection guide, not a substitute for a site-specific engineering inspection, manufacturer requirements, local codes, or professional safety procedures. Inspect during calm weather. Do not inspect during lightning, high winds, flooding, ice, aggressive wave action, or any condition that makes dock access unsafe. Wear appropriate personal protective equipment such as a life jacket. Work with another person when possible, and never enter the water or crawl beneath a structure unless you are trained, equipped, and authorized to do so. Always take photos before touching anything. Avoid walking on the dock if it appears unstable. Remember, safety first. So start the inspection before stepping onto the gangway. This diagram shows the 10 critical areas to inspect regularly for a safe, reliable dock. Record the inspection date and time, weather conditions, approximate water level, recent storms or flooding, unusual wave or boat wake activity, known collisions or overloading, previous repair items, and have current photographs of the entire system. Water level matters because it changes the gangway angle, transition geometry, anchor loading, and the way the dock interacts with piles or guide systems. Inspecting at different seasonal water levels can reveal problems that may not be visible during one visit. So before walking onto the system, look at the dock from shore. Does it sit level? Is one section lower than another? Does it lean, twist, or move excessively? Are there any modules separating? Unexpected listing or uneven freeboard can indicate damaged flotation, trapped water, structural distortion, uneven loading, or a failed connection. If you don't remember what freeboard is the distance from the surface of the water to the top of the dock. Now step onto the system carefully and pay attention to how it responds. A floating dock is supposed to move. The concern is not movement by itself. The concern is unexpected, uncontrolled, uneven, or excessive movement. The walking surface. You want to inspect every deckboard or panel for rot, splits, cracks, loose fasteners, raised edges, soft areas, missing sections, sharp projections, slippery algae or biological growth, oil, grease, or standing water, uneven transitions. Dock inspection guidance commonly emphasizes secure walking surfaces, sound structural connections, usable handrails, and surfaces free from deterioration and protruding fasteners. Test suspicious areas carefully without jumping or creating unnecessary impact. If deck panel flexes significantly, sounds hollow, or moves independently from the frame, mark the location and restrict access if necessary. Next, examine the structural frame. For aluminum, steel, wood, or composite systems, look for cracked or incomplete welds, corrosion, bent framing, loose bolts, elongated bolt holes, missing hardware, failed brackets, rod or insect damage, split structural members, improvised repairs, or connections pulling apart. Pay special attention to module-to-module connections because repeated dock movement can loosen hardware and enlarge connection holes. Polypropylene floats. If your dock sits on plastic poly floats, look for cracks or punctures in the shell. These let water in and the float starts taking on weight. Check the seams and corners especially, since that's where stress cracks usually start. Also watch for ultraviolet degradation. Chalky, brittle, or faded plastic means the float is breaking down and is more likely to crack. And look at how the dock sits in the water. If one section is riding lower than the others, that float is taken on water and needs to come out for inspection. A wood deck with flotation. The flotation could be foam billets, encapsulated foam, or barrels underneath. With foam billets, check if they're wrapped or encapsulated. Exposed foam breaks down, absorbs water, and gets heavier over time, which is what causes sinking. Look for chunks missing or a crumbly texture. Same check here. Is there any section sitting lower than the rest? That's your sign a float is waterlogged or failing. And since this style has a wood frame and deck, also check the wood itself for rot where it meets the water. That's the area most exposed to constant moisture. Now, concrete floats are the most durable, but they're not indestructible. Look for cracking or spalling. That's where the surface flakes or chips away, often exposing rebar underneath. Corners and edges take the most impact, so check those closely for chipping. And again, check that every section is sitting level and at the same depth in the water. Uneven sitting on a concrete float usually means water intrusion into the flotation chamber, which is a bigger problem. Now inspect the visible flotation. Look for cracked float shells, punctures, water inside floats, missing floats, broken attachment points, uneven flotation, exposed or deteriorating foam, floats rubbing against rocks or structures, marine growth affecting access or performance. Do not assume that a dock floating above water is in good condition. A partially flooded float may still provide some buoyancy while creating uneven loading across the dock frame. Inspect rub rails, bumpers, cleats, ladders, utility pedestals, dock boxes, and other accessories. Check that each item is securely mounted and does not create sharp edges or trip hazards. Pull on cleats by hand only when it can be done safely. Do not perform a load test unless the test method has been approved by the manufacturer or a qualified professional. A loose cleat may indicate more than a loose bolt. The mounting structure beneath it may also be damaged. The anchoring system keeps the dock in position while allowing necessary vertical movement. The system may use guide piles, cables, chains, anchor arms, stiff arms, shore anchors, deadweight anchors, helical anchors, a combination of systems. Start by watching the dock as a person walks across it or as a small wave passes. Does it return smoothly to position? Does it strike the piles? Does it pull hard against one anchor point? Does one corner move much more than the others? For pile-guided docks, inspect banter-leaning piles, corrosion near the waterline, cracks, loose pile caps, excessive pile wear, damaged guide brackets, missing rollers or pads, binding, excessive clearance, signs that the dock is climbed or jammed. Rollers and guide brackets should move without binding while keeping the dock properly controlled. A pile that is visibly leaning or a guide bracket that repeatedly slams against the pile may require professional evaluation. Inspect visible chains and cables for corrosion, broken strands, kinks, abrasion, loose shackles, missing pins, distorted links, uneven tension, contact with sharp surfaces. Inspect anchor arms for bent members, cracked welds, loose pivot bolts, worn bushings, damaged shore connections, restricted movement. Never adjust a heavily loaded cable, chain, or anchor component without understanding the stored energy in the system. If the dock includes electrical, water, fuel, communications, or fire protection systems, perform only the visual checks you are qualified to perform. Look for damaged conduit, loose utility supports, cables stretched by dock movement, exposed wiring, broken covers, corroded enclosures, leaking pipes, unsupported hoses, connections rubbing against metal, utility crossing walking paths. Electrical systems near water present serious hazards. Do not open equipment, touch damaged wiring, or attempt electrical repairs unless you are properly qualified. Restrict access and contact a licensed professional when electrical damage is suspected. Now inspect the gangway from one end to the other. A gangway is a variable slope pedestrian connection between a fixed structure or land and a floating structure. Because the dock rises and falls, the gangway's angle and transition points change with the water level. Begin at the shore side support. Inspect hinge pins, mounting plates, welds, bolts, concrete anchors, timber connections, bearing surfaces, corrosion, cracking around anchor points, signs of uplift or separation. The gangway should be securely connected while still allowing its intended movement. A loose shore connection can create sudden shifting and may transfer abnormal loads into the gangway frame. Look down the length of the gangway. Does it appear straight? Is it sagging, twisted, or bowed? Check the main side members, cross members, bracing, welds, bolted connections, expansion joints, bearing points, protective coatings. Inspection guidance for gangways commonly includes checking for distortion, cracks, corrosion, and degraded connections. Inspect the walking surface for loose grading, broken boards, missing fasteners, uneven panels, excessive deflection, sharp edges, slippery buildup, debris, ice, ponding water, openings that may trap footwear or mobility devices. Walk slowly and listen for rattling, grinding, popping, or clicking sounds. Those sounds may indicate loose hardware, contact between structural components, worn rollers, or movement at a connection. Check both handrails from beginning to end. Look for loose posts, bent rails, missing sections, cracked welds, sharp edges, excessive movement, corrosion, openings created by damage, connections separating from the frame. Apply only light hand pressure during a routine visual inspection. Do not conduct a formal load test without an approved procedure. This shows what they're talking about how water level changes the gangway geometry. When the water level is high, or water level is low, is a steeper angle to go from the land down to the float. Normal water level, this is what it's designed for. And then when the water's high, it's a much flatter angle to get to your dock. If this video helped you to inspect a floating dock and gangway, click like and subscribe for more practical videos covering marina design, dock construction, waterfront safety, shoreline protection, and marine infrastructure. And comment below, what is the most common dock problem you have found? Is it loose decking, damaged flotation, corrosion, or failing anchoring? Share your answer below, and please include whether your dock is located on a lake, river, reservoir, or coastal marina. If you'd like a copy of the blog of this video with all the diagrams and lists, message PJ with the title of the video at pj@pennyvaledocks.com. Thank you.